temperature indicator or DTI by Dr. Pichaya Patana Satawong, CEO Cleantech and Beyond, Assistant Professor with Tech and his business about research in related about semiconductor, advanced material, electronic device. So ladies and gentlemen, without further ado, please give a big round of applause to welcome Dr. Pichaya ค่ะขอเสียงปรบมือต้อนรับค่ะ
Thank you. Hello. Okay, so thanks very much for the introduction, and thank you to Andrew for the invitation for Cleantech and Beyond to present our technology at this event. Okay, so I think today is a very good session. In the morning, we already learned about different kind of materials used in different active and intelligent packaging from Professor Pierre. Our technology is also based on our patented thermal-responsive material. Okay, that is the key technology of our DTI. And we also learned from Andrew about like different technologies from the QR code, and also what we do is, and we use RFID and NFC. So this is a very good continuation for the talks. Okay. Right, why it's crucial to track temperature. So what our technology does is that it tracks temperatures. Okay. The critical temperature specifically, and it can track pharmaceutical products, or actually food and other things as well at item level. Okay, and because we were in the pharma event, so the pharmaceutical industry is losing like $35 billion per year, and this is due to the failure of temperature control logistics. Right, so many pharma products have to be kept under safe storage temperatures. Okay, and the financial loss here, this is just basically the tip of an iceberg, right? Because beyond the financial loss, when we lose all these products, it means that we are also losing valuable resources that have already been used to produce the pharma products, and also the other resources like water, energy, labor, time, and also when they are damaged, we also need to dispose of them, right? So there's also the environmental cost of the disposal, cleanup, and also can lead to more environmental impact as well, the negative ones. Right? Then this is a summary again. So apart from the economic impact, we have environmental impact. Oops. Okay, and then the ethical considerations, like all of these lost medications could have been used to actually give more access to healthcare to the population. Right, but instead they're all lost due to incorrect temperature control, and also some of them may be inadvertently, or they don't know that actually the medications have already been degraded due to high temperatures. That also poses the risk about the inactive or ineffective medications that could endanger the public's health. So then temperature tracking technologies, what we are focusing on, so can help prevent losses and also improve the business sustainability, less loss, less wastage, right? And ensure the delivery of safe and high quality products. And this is what we are presenting, the digital temperature indicator. So it's a new solution. Battery-free operation, so it does not need a battery. That allows item level temperature tracking, and it has a wireless digital interface, allowing the linkage with the backend IT system for inventory and logistics management systems. And we've already heard actually from the two speakers this morning the importance of the smart packaging. How can active, intelligent, smart packaging help? Right, not just protecting them, making sure that the products after manufacturing point can be delivered to the customers. Right. They can also help monitor the environmental conditions. So my pointer, okay. Temperature, so this is the first one that we are focusing on, okay. And in the future, we will expand to other environmental conditions as well, like humidity, UV gases, and so on, okay. And then with the, so the QR can also connect the physical products to the digital world, but for us, we are focusing on the digital interface using RFID and NFC. Okay, and actually Andrew already mentioned that then we can scan many items at the same time. There's no need for the line of sight, which is very suited for high volume tracking of billions of products that go around the world. In this case, and eventually they will help reduce the losses and also improve the sustainability, okay, and the quality and safety of the products, of course, yeah. And eventually for the brand owners, then if you can make sure that the products are delivered safely, right, still retaining high quality to the customers, then that also increases the trust and the engagement with the customers. Many of the especially active data lockers are already available, actually, right? But it's got batteries. And what we are doing here is that we are making something that can be used to track at item level. Okay. So recently, for example, with the COVID pandemic, there was already an issue of vaccines when they ship. We know that COVID vaccines have to be stored under at low temperatures, right? And they are normally tracked in like maybe one box containing several hundreds, but not at the item level. And there were already cases where each vaccine bottle has been left at room temperature for too long, and then the vaccines become ineffective, right? So in that case, then the active data locking that tracks, not a single item level, then does not track all the way until the usage point. But what we are trying to do here, what our technology presents here, is that we can track down to the individual item level from the manufacturing point down to the end point. So by surveying what is available in the market right now, we define 3 key characteristics. Okay. So the first one is the digital interface or wireless communication that allows the linkage of the physical product and the digital world, and then link that to the enterprise's inventory management system. Battery-free operation. So this is for the item level tracking, basically. So by making the labels battery-free means that it can be scaled down to smaller size, and also there's no worries about environmental impact from the disposal of the battery waste. And the data locking capability. So this one here ensures that it has a thermal history. Okay. So and in this case, what customers or what really matters is a yes or no, whether or not the temperature of that critical point has been exceeded. So let's see. So the electronic data locker. Okay, so this one definitely has a digital interface, right? Full digital functionality, and also track the thermal history very accurately and also in high details. So you know the full thermal history of the products. But in this case, it needs a battery, and then not very good for item level tracking. Okay, and there's also actually the battery life. Second one here, the passive RFID. So RFID is now used in retail industry already for checkout. Okay, so where you don't need to scan the barcode or scan the QR, just pass the items through the reader. Okay, so many retail now uses that. So there's no need for the line of sight. And some of the RFID chips have temperature sensing functionality. So in this case, yeah, through the RFID, then we can use RFID to scan with the digital interface, okay, and there's no need for the battery for that because it harvests the radio frequency basically from the RF, okay, but then there's no data locking capability. So this one, you only know the temperature when it is being read with the reader. So if something happens along the way, for example, you ship the product from one point to the other, you will know only when you're reading it, okay, don't know if something happens along the way. For example, if the container sits in the tarmac in an airport, the temperature goes high. But then later, it is been sent to the storage in the warehouse, and the temperature goes down again, right? So you will not know that, oh, at that one point, actually, something might have happened already. The temperature indicator label. So Professor Pierre already mentioned this morning, okay, many different ways of mechanisms that how they can work. Okay, so this one doesn't need a battery. It's based on the physical, chemical, photochemical reactions, different kind of material characteristics. So it works on its own. It does not need a battery. So that's very good. It also provides a data locking capability because once it's changed, okay, so there can be designed such that it goes one way. It changes, for example, the color changes from white to red, and then it does not change back. Right? So that is the data locking capability, a yes or no, basically. Okay, it's not. It does not provide like the full function of data locking like the electronic data locker. Okay, but in reality, for all of these products, we only need to know that one crucial point: has the critical temperature been exceeded? So our novelty is, and we combine all of these three together. So the DTI, or digital temperature indicator, okay, combines the digital communication, battery-free operation, and also data locking capability. Okay. So the product concept is we designed it based on the passive RFID. So the communication part here is the usual RFID. So the basic infrastructure of RFID, and also we have the NFC function version as well. So easily, seamlessly integrated into whatever already exists in terms of RFID and NFC tags. Okay, we just add this extra part of the self-operating sensor. So this one here is based on our patented thermal-responsive materials. Okay, so I'll speak a little bit more about this, how it works. Okay, and the tag then gives dual indications. Okay, so we keep the visual. The visual is actually something extra we add to make it, let's say, similar to the TTI. So many people in the industry are already familiar with how the TTI works, right? So the color changes. So we add that visual indication as well. But what really is important in our one is that the digital status is also changing, and this is from the electrical characteristic of the material. And by combining this together, so we allow a digitization of the temperature label. So basically digitizing the TTI. Okay. And with the thermal-responsive material, we also engineer the property to be irreversible. And that gives the data locking and tamper-proof temperature recording. So a bit more on the material. So this is basically like during the developments, like how we were doing the thermal-responsive, that we use this to make our sensor. This is an example of like the non-optimal formulations. Okay, so something that didn't work when we were doing the research. So this graph shows the electrical properties. Okay, on the vertical axis, and then the horizontal axis is the time. So we start heating at this point, stop heating. The non-optimal formulations, for example, this one here is too conductive, and it doesn't change, so we cannot use this to indicate any status. Basically, it does not change with the temperature. And then the blue line here, okay, thermal responsive, so it changes with the temperature, but then when it's cooled down, it changes back. It reverses back to the original status. And this is actually the normal property of materials. So typically, the electrical property of the material is a function of temperature. So when the temperature is high, it changes to one direction, but when it's cooled down, then it changes back again. Okay. So if we use this one in a tag, okay, at the beginning it's okay. Once it heated, okay, the product degrades. Okay, the tag gives warning. So it for example, status goes from green to red. But then when it's cooled down, the product, right, has been lost. The product is not reversible. The medications or food and any temperature sensitive products have been degraded already, but the tag would go back. So in this case, it would give a false status. So this is like for pharma and medical products. Actually, this is dangerous. Right? The products or the vaccines may not be effective anymore, but then the tag still says, oh, it's still okay. So this one doesn't work. But then we managed to formulate a thermal responsive component that once we stop heating, we cool it down, it stays in that state. Okay. So here the resistance goes from high to low, and then it remains there in that low resistance state. Okay. And when we use this in a tag, right, so it goes the same way, heated, and then it's spoiled. And then when we cool it down, the tag stays as red in this case, in this animation here. So it gives a warning. It does not reverse back to the initial status. Right? So that is the data locking function of our thermal responsive composite. And we also make sure that after that, doesn't matter how we cycle the temperatures again, it can go up, it can go down, we can cool it down to very low temperatures, it will not change back. Okay? It stays in that second state. And when we put this in the DTI or in our smart level, okay, let's see the device status. We also actually have the we have the room temp to higher temp. That's one series. We also have the lower temp one. Now we have the prototypes, and then they will come out next year. Okay. So in this case, we can manufacture these tags at room temperature. Okay. And then when we want to use it at low temperature, we can apply it into the cold chain. Okay. So the temperature goes down, and then we start activation. Now the tag starts to work. Okay. So with the activation step, after cooling it down, it would start to sense the temperature. Okay. And in this initial state, like this one here, we are showing the NFC version. So we can use a smartphone to scan. It will show like the normal status here. Okay. And then once the temperature goes above a critical temperature, so it's called a temperature excursion event. This one here, then the device status would go from a non-triggered state to a triggered state. Okay. So the color would change, and also the digital status will change, which can be read through smartphone for NFC or through the reader using RFID version. And it doesn't matter like how the temperature fluctuates afterwards. So after that first temperature excursion event, okay, that state would remain, meaning that this warning status here is tamper-proof. So let's see the RFID in practice. So we have two versions here, Android and iPhone. And we work with our partners to make sure that you don't need an app. We have so many apps on smartphones right now. So just enable the NFC function, tap on it, and then it will bring up the internet browser. You can read the status directly from that. Okay. And once the temperature goes above the threshold, the color will change, and you can also read with the mobile phone. Okay. Sorry?
Every product will have its own stability data. How do you record that? Because certain products, the label will say certain temperature.
Oh yeah, so we would need to work with our customers, and then we can have different formulations. For example, this one here we're showing that's 40 degrees Celsius. But if the product is sensitive to 25 or 30, we can formulate our sensor to match with that temperature. Yeah, so different ones would have the matching with the products that they would like to track.
There is a timeline also for that. So for 25 for 4 hours, 43 for 4 hours.
Okay. This one here, the one we're showing, the one that we are ready to sell right now, it's a critical temperature. So the time is very short, but we have the next version with the time delay, which can be customized as well. If you want 15 minutes, 30 minutes or longer, we can customize the time that it would detect the temperature. Yeah. Thanks. And then with the RFID version for logistics in this case, then we can use a reader to read. For example, in this box here we have I think 64 boxes inside in this animation. Okay, and then just one scan. So we don't have to scan it one by one, and we don't even have to open the big box. So 64 items inside, scan one time. We have the data, like 60 of them are normal. Okay, 4 of them have been exposed to high temperatures, and well, depending on the kind of reader, but we know that it is available. We have tested already. If the reader is like large enough, you can also locate in 3 dimensions which boxes have been exposed to high temperatures. So here in this case, we have the location in XYZ coordinates. And you can go and then pick out the ones that have been damaged by temperatures. Okay. So imagine if you have like, a huge container or a big carton, right? Go through an RFID reader, it identifies immediately, like you can just go and pick out the spoiled items. So this one here improves a lot on the sustainability, because the current practice right now, you detect something is wrong, typically they destroy the whole container or the whole carton. Right? But in this one, you can identify which one is bad. Right, so our key competitive advantages are these 6 parameters here. So critical temperature indication with dual outputs. And yes, thank you for the question. We also have the time delay one that will come out soon. Okay, and fully compatible with the existing RFID and NFC infrastructure. So there's no need to change the reader. The normal smartphone, the NFC smartphone would work, and also whatever is already the enterprises are using for RFID tracking and logistics would also work as well. Just need to pick out one extra information, which is another data field basically. So this one is easily done using like the IT system. Pick out the field to read the temperature. Is it a yes or it is a no? Battery-free operation from our thermal-responsive composite. Okay, so all of this then allows us to make the tags to be quite cost competitive. Right. Okay. And with this, then we allow them to be used to track at item level. Okay. And with the NFC version, also support the self-verification by users, so it can track all the way from manufacturing point to the shelf, and even after the consumers buy them from the shelves, put them at home. Sometimes like we don't really know if we keep them under safe temperatures or not. We can continue to track with this one all the way until the point of usage. So our team here, so we mostly material scientists. Okay, so my background is also material science and also physics. Work with advanced materials, semiconductors, and electronic devices. And we have a very talented team of researchers, also mainly chemistry, material science, and engineers in the R&D team. And also we have our innovation advisor and also co-founder of the startup actually, with 20 years of experience in the RFID business. Okay, so we integrate basically our backgrounds in terms of RFID and NFC levels with advanced materials to make the DTI possible. And so the project we conceived the idea in 2018. We started to do the research 2019, and then proof of concept about 3 years until last year we got the TRL9 prototype, and then this year we are launching the startup. Right? And since we started to go public about our invention, then we already got some acknowledgements from, for example, NFC Forum, so one of the finalists of the Innovation Awards of last year. BDMS, this is I think the largest healthcare and hospital groups in Thailand. So we joined started pitching for smart hospital. We show like how the DTIs can be used to track, for example, blood bags and also pharmacies in a hospital setting. And this year we are also joining Packaging Europe as one of the finalists for the Sustainability Awards, okay, in the category of active and intelligent. So we'll be in Amsterdam later this year in November. And our invention has been picked up, for example, by RFID Journal, had a feature article about this. And also from joining IPL last year, we were chosen as one of the Congress's highlights as well. And for the startup right now, so we are scaling up and then expanding the team. So we see a lot of, actually recently we see very interesting technologies in terms of like sustainability as well. Like we can integrate sustainable materials into how we pack our devices. So make them more sustainable overall, okay? And also we are looking a lot to work with brand owners and also the system integrators, smart packaging industry, and also the brand owners to do use case study and also pilot projects together. So that is the end of the presentation. So thank you very much for your attention, and thank you again for inviting me. Thank you.
Wonderful speech. Thank you so much, Dr. Pichaya, CEO, Cleantech and Beyond. All right, so ladies and gentlemen, anyone, if you have any question, you can ask our speaker right here. Before, we will let everyone to have some lunch. All right, okay, and we will come back again for the next session at 2 p.m. For the next topic, okay, we'll begin at about 2 p.m. All right, so I would like to welcome you guys come here once again. Anyone to have any question to our Dr. Pichaya มีใครมีคำถามไหมคะ about tracking temperature sensitive pharmaceutical products at item level with battery-free digital temperature indicators, or about any details about this one topic? No one have, right? Okay, Doctor ค่ะ okay. Yeah, please.
Thanks very much for an inspiring presentation. There's huge potential. You know, you highlighted that potential in the cold supply chain and the loss that there is in the cold supply chain, and it really came to the fore during COVID-19 of how much COVID vaccine was being destroyed because of lack of this technology being used in that area. Have you or your organization commenced some discussions or interfacing directly with pharmaceutical companies, not only here in Thailand, but worldwide? Because there's a phenomenal opportunity. The World Packaging Organization works with Sustainable Medicines Partnership, and they reflecting similar figures there in terms of the losses. So the opportunities are there.
Yeah, thank you very much, Professor Pierre. So, in truth, we have not really connected with the pharma producers yet. Okay, but that is very much something that we look forward to. So right now, for the prototypes, we have the lower than room temperature already working. Okay, but I think we need a little bit more time in order to deploy them in like real use setting. But we also very much would like to start, discussing, especially we would like to learn about the specific requirements, like what is like the actual use, and how sensitive the temperature is, the time, for example, that the audience mentioned. Yeah, but yeah. So thanks very much. If we could also maybe get some more connections later.
Publicly, I'll say that as soon as you're ready, talk to us, the World Packaging Organization, and we'll put you in touch with Sustainable Medicines Partnerships. They're based in London. And so all the big multinational companies belong to this organization looking at sustainability of packaging. And this is all part of that. And they want to reduce that figure that you mentioned there. So they are they would be open and welcoming ideas of reducing their losses.
Yeah, thank you. So we'll keep in touch. Stay.
Thank you so much. And now one more question.
Doctor, that was a beautiful presentation, and it was really impressive. I worked with Pfizer, so as a customer requirement, see, there is a requirement for a temperature control shipment saying that it has to be recorded because the temperature needs to be recorded at regular intervals. So do you have that in your mind? Because just a sensor is going to help you out to record the temperature, but it has to be recorded at regular intervals. Do you have that in mind going forward?
So right now, let's say we started to discuss with one partners in Europe that they have this based on a different or not passive RFID. But so basically we can integrate the sensor with the different communication protocols, for example Bluetooth. So if the container has readers inside either RFID or Bluetooth, and then can do the regular intervals of communication, we can also use this we have started to talk about like how we can integrate this into that system as well. Yeah.
Because when you're taking the transportation on the logistics perspective, for an end-to-end transportation for an ocean, they are just looking out for a maximum recording of 60 days. And for the air transportation, it is between the maximum recording is 10 days. Okay. So they will be requiring that kind of this thing. So just a kind of a customer's input. Just wanted to tell you that.
Thank you. Yeah, this is like very valuable comments that we would like to know, like the actual use case, like what I was showing like near the last slide. So we would like to basically we are a new startup. We are now trying to learn more like the requirements from the industry, like the actual ones, so we can integrate this into our products. Thank you for the comments.
Thank you so much for our guests and audience today for your question to our doctor right here. And any questions, sir? Do you have any question to ask for more details about this one? No more. Okay, great. So great and excellent.